on to our third speaker. It's going to be Gayle Zydlewski. He's going to talk about fish interactions with marine renewable devices, lessons learned from ecological design to improving cost effectiveness.
Thank you, Ben. I'm going to try to move this. There. So as you can see, I'm not the only person working on this project, and as with many people here, we're all working as a team. So I just want to acknowledge the other folks on my team of folks working on this project. I guess I used this picture simply because, and it follows through nicely on Tony's, fish do behave, and so they're not passive particles, and we need to really consider what they're doing at various different scales. So this is where we are, roughly, and that's a big spot covering your whole island there. And I thought I'd give you a context of where I'm coming from, which is the mouth of the Bay of Fundy, and we've heard a little bit about that earlier. And the work that we've been doing is in the state of Maine, and Jessica talked with you about that this morning. And I'll be particularly talking about a small, a relatively small bay, I suppose, Cobscook Bay, and I'll keep referring to that bay as I go through my talk. We've worked closely with Ocean Renewable Power Company, and just to be clear, I'm from the University of Maine, so I'm from an academic institution. We've been doing research on this project related to fish interactions with the device. So this is a horizontal cross-flow turbine that they deployed in 2012. This is just the bottom support structure going in the water at that time in March of 2012. So our question is, what is the probability that a fish will actually encounter an MHK device? So as this device went in the water, we started asking multiple questions that would inform, or started collecting data to inform this question of what is the probability that a fish will encounter the device. And you've already heard a little bit about the questions of how do you define near field, how do you define midfield, how do you define far field, and I'll define them for the way we've done them in our project. And the work that we started on, we wanted to look at near field interactions with the device, and I'll tell you a little bit about that work, and we have a publication that recently came out on that. And then we've defined far field, at least initially for this project, to be about 1 kilometer away from the device. And this is where we've collected a lot of what we're calling baseline data previous to the deployment of this single device anyway. And then there's, we're just starting on some work where we're looking at midfield, because we think this idea of somewhere not right at the blades, but as you move away from them is where fish and other animals may be avoiding these devices. And we really want to pin down where that might occur. So really, avoidance can occur at multiple different levels, at spatial scales, and what we want to do is try to pin that down a little bit. And really what we're interested in is when are fish, where and when are fish in this part of the water column, because ultimately we want to know when they're going to be, what happens when they're encountering this device, and will they ever be in that zone as they're approaching the device. So I want to pause a little bit here. We've heard a lot from people about different space and time scales, but we've also collected data. This is again the bay that I'll be talking about. Here's the one device. It's relatively to scale there. But we also want to consider, this is about the 1 kilometer space that I've been talking about, as well as kind of far field. And I want to keep in mind the fish as we talk about these things. And these are data that we've collected. And as a developer is trying to identify a space to actually deploy a unit, you can see that the assemblages of fish change over different spatial scales. And those things need to be considered. And so we just have different assemblages of fish in different spaces. But not only that, over time these assemblages change as well. And so we're not just looking at one life history stage during some time of year. We might be looking at multiples depending on when you're actually out there doing your work. So it's important to think of both space and time scales, and hopefully I'll hit all of those as I go through the rest of my talk. So the first study we did was, everybody's worried, and we're still all worried about what happens when an animal interacts with a device. And so we started some work when ORPC was going in the water with their beta device. And we did send acoustic cameras around that device. And actually one of my colleagues was here last year talking about, at the last conference talking about this work. So I'll kind of breeze through it a little bit, but I'm happy to talk about it more later. So we, on the research barge where they tested the beta turbine, we put 2 Didson acoustic cameras to get an idea of what's happening in this near field, literally within 5 meters of the device. This is just a schematic of that device, just to give you an idea of what we were looking for. We were looking at both approach behaviors as well as departure behaviors, but I'm going to focus on what happens when fish approach a device. And what we wanted, we did a lot of characterization of the types of behaviors that we saw, but really what we saw over a period of time was about 50% of the fish never interacted with the device within that near field, that 5-meter window that we were looking at. So 50% of them either went by above or below the device. And about half of them, 48%, then actually went through the device. Now, I can't tell you much of anything about what happened when they went through that device, but I'm happy to tell you more about what happened when they came out of it. We also looked at, we really were hoping to see more of this active avoidance, what happened. And we were able to quantify behavior in that zone. But about 1% of the fish, and I'm talking thousands of fish we looked at over this time period, actually showed some type of active avoidance. So it was interesting to see that behavior as well, but most of the fish actually did go through the device. So that's the work that we've done in the near field of the device, and what I'll do now is kind of build the picture of what else we're looking at to build this model. So in terms of far field, I've already talked about the project site. Now you'll notice the turbine isn't there, because this work started before the turbine went in the water. We started monitoring fish distribution in the water column at the project and a control or reference site within the same bay. So what this looked like during the initial stages was surveys using acoustics, active acoustics, to look at the density of fish in the water column so we could get ideas of abundance over time, really seasonal patterns of how many fish we might see. So we also did this at this reference site, which is about 1 kilometer away, and obviously we can debate what far field is, but that was our far field for now. When the turbine went in the water, and I'm going to flip back here if you notice this part of the slide here, what happens when you go and you study a site when the turbine's not there with acoustics, you can sit over it. But when the turbine went in the water, we had to adjust our project site to be around the turbine so we can get information of distribution of fish in the water column. And I'll come back to that in a moment. So really what we wanted to look at are 2 different things. The first one was seasonal patterns of relative abundance. So what we saw in the control or baseline period, and this is just 1 year of data, but we have actually 2 other years of data that show similar patterns. We looked over time at this project and reference site, and really there were no differences in abundance at the 2 different sites until the device went in the water. And what we did see is these are actually statistically different from one another. But when the bottom support frame went in the water, we saw a higher abundance at the control or reference site than we did at the project site, which may indicate avoidance of that project site during construction, and this is relatively anecdotal, although it is statistically significant. But what you see also is when the turbine was deployed, so these are 2 construction periods, right? So we just heard a lot about noise around those times. We saw a difference, a statistically significant difference in abundance at that site, which is, as I said, anecdotal, but something to keep in mind. So what we're really interested in, as I mentioned earlier, is what are the proportion of fish at different depths in the water column. Specifically, how many fish are in this part of the water column at these different scales as you approach the turbine. And this is a distribution of 1 meter bins in the acoustic data, so we could look at the relative abundance of fish in all these different bins of the water column. And again, just to remind you, the project site divided when we went from our baseline period into a beside and inline site, because I'm going to show you some vertical distributions. So again, baseline data, we feel like our project and control sites were relatively similar to one another based on the vertical distributions that we documented over the baseline period. However, when the turbine was in the water, we did see some differences in vertical distribution. And this was in March of 2013. This is the depth of the turning part of the turbine, and this is below that, where the bottom support structure was. But what you can see is that these letters indicate statistically significant differences. And the inline and beside sites actually have somewhat different vertical distributions. They may be difficult to see, but in the beside site, we have higher density at the level of the turning turbine and lower densities at the inline site. And I have all kinds of ideas of what that might mean that I'll be happy to talk with you about later. So maybe this is evidence of avoidance of the site. or of the turning turbine. Possible avoidance also during construction, as I mentioned, may be indicated by decreased density at that project site. But as you notice, this is only one survey that I'm showing you while the device was in the water, simply because it didn't stay in the water operating for a very long period of time. So we simply need more information to inform this. So I just talked to you about the near field and the baseline data, essentially, in the early stages of looking at the device in the water. And what I want to do now is talk about the midfield and the approaches that we'll be taking to look at what's going on in this area that's between the far field and the near field. And we'll be using mobile surveys. We've actually done some preliminary work, so I'll give you some idea of what that looks like, and then how this all will be pulled together ultimately. So we're going to use mobile acoustic surveys going over the device, and I'm going to show you a period of preliminary data we collected. This was in March of 2013. We did multiple transects over a device, and before I bring up the data, what I will tell you is this was March. There just simply weren't a lot of fish around, so we don't have a lot of data to go on yet, but it's very promising. This is what it looks like when you float or do acoustic surveys over a turbine, this type of turbine anyway. So here's the bottom support structure. This is the actual turning part of the device. And what we're doing is looking at the density of fish in the upstream, so we're floating with the current over the device, and we can look at fish tracks in all these different zones of the device. And again, the numbers are fairly low here, but what you can see is we can look at the number of fish over time as we're going past the device to see what fish are in which parts of the water. And this is kind of I'd love to talk with folks about this wake area because it's giving some indication of attraction behind the device, which we're hoping to explore further. So putting this all together, we're hoping to integrate across this project using a probability of encounter model. And what I've shown you so far is kind of the different area or different surveys that we've used to generate some data for this purpose. So within this, the near field of the device, I showed you that only about 1% of the fish can actually avoid at that level or in that zone. So we're really interested in what's happening in this other part of the spatial scale, or spatial domain. In the far field, we've collected proportion of fish in these different parts of the water column when the turbine was not present and when it is present. And then with the mobile transect, we're hoping to get another idea of what's happening, the probability of fish being in that part of the water column as you approach the device. Keeping all of this in mind, I just told you a lot about space and a little bit about time. All of these are a function of time of day, tide, month, and year. So I don't want to leave you with the idea that we only did this during any one of these. We're trying to do these over time and trying to use the knowledge that we're gaining at all of these different temporal scales to inform these spatial scales as well. So that's most of the picture. A little more about temporal resolution. You'll notice that I've pointed out we've used boats for all of this work. I'm a little bit jealous of all of the Scottish folks who have been talking about pods in the water and integrated packages that could be put next to these devices. Really, to be honest, this device went in the water fairly quickly, and we really didn't have the funding to develop an integrated instrumentation package. So we did our surveys over 24 hours, hoping that we could capture at least the variability from day to night and over ebb and flood tides over that 24-hour period. Since that time, we have installed a sonar in the area of the device where we're collecting data. Actually, the device is no longer there, but we're collecting fish density data 24/7. And so we're hoping to collect that over a 30-day period to give us an idea of, well, first of all, we're able to collect behavior of fish in front of a non-turning turbine, essentially. It's actually only the bottom support structure. But we're hoping to gain from this is to determine a sampling periodicity that we can say that whether or not our 24-hour samples are really representative of what we want to say for a season. And so with that, I'd like to acknowledge the folks who have helped do this work as well as help funding this work, and for those who helped me come here to Scotland. Thank you all.
Thanks very much. We have just a few seconds for a quick question.
tidal stream at this site?
It can get up to 4 knots or 2 meters per second. That's the high end. So it's not like the 6 knot or 6 meters per second that you saw in the Bay of Fundy. It's on the lower end of the Bay of Fundy. So it's and the thing that's interesting about the site is it's manageable. You know, we can do this work in that site. At the same time, it doesn't represent these really dynamic sites.
Splendid. Okay.
There's,
Yeah, go, Kim.
You mentioned that just very tentative at the end. You mentioned that in the wake there was possibly more fish there. Do you think those fish come from the outside, or do you think those are fish that have come through the bait and then stayed there?
well, if you think I was tentative with what I said, I'm going to be even more tentative about answering your question. It could be either. And we have, like I said, we did only 8 transects over that device, but every one of them, there were more fish behind the wake than there were in front of it or in any other location. So it was pretty telling, but we're hoping to collect more information about that.